Hello children, welcome back to your 7th standard General Science digital class. We continue with lesson number 7, motion, force and work.
Now let's see a few numericals which are there in this lesson. Question number 2. The question is, observe the figure and answer the questions. You have to refer the textbook for the question. I have drawn the figure here. So the question is, Sachin and Samir started on a motorbike from place A, took a turn at B, did a task at C, travelled by the route CD to D, then went to E. Altogether, they took 1 hour for this journey. Find out the actual distance traversed by them and the displacement from A to E. From this, deduce the speed. What is their velocity from A to E in the direction AE? Can this velocity be called the average velocity? So let's understand the question. Sachin and Samir started from A. They travelled up to B. Then they took a turn and went up to C. From C, they travelled up to D, and from D to E. The question is to calculate the speed and the velocity. To find the speed, we need to know the actual distance travelled. So what's the actual distance travelled? Yes, it will be the sum of the distance travelled by the two of them. That is AB plus BC plus CD plus DE. So let's write, add all the distances, you will get the total distance travelled. That is equal to 15 kilometers. Now in this process, the two of them are displaced from A to E. This is their initial point and this is their final point. So if you add up these values, you will get the displacement. So the total displacement from A to E is 3 plus 3 plus 3, that is 9 kilometers. Now let's find the speed and velocity. Speed is equal to total distance upon time. What's the total distance? That is 15 kilometers divided by the time taken is given in the question as 1 hour. So 1 hour. So you can write speed is equal to 15 kilometers per hour. Now let's see the velocity. Velocity is displacement upon time. What is the total displacement from A to E? That is 9 kilometers. So 9 kilometers upon the time taken is 1 hour. Therefore velocity is equal to 9 kilometers per hour. The velocity from A to E can be called the average velocity. Now let's see question number 4. A bird is sitting on a wire, flies circles around and comes back to its perch. Explain the total distance it traversed during its flight and its eventual displacement. The question says, a bird sitting on a wire flies circles around and comes back to its perch. Now what is meant by a perch? Perch is an object where the bird sits or rests. Now let us say that point A is the initial position of the bird and it is going in a circle. So what will be the distance travelled by the bird? Yes, the distance travelled by the bird will be equal to the circumference of this circle. Now what is the displacement? Yes, the initial position of the bird is A. What is the final position? Yes, the final position is also A, because it is said that it is coming back to its perch. So its initial position and final position are the same. So is there a displacement? There is no displacement. So the distance traversed by the bird is equal to the length of the circumference of the circular path, and the eventual displacement of the bird is 0 because it got back to its original place. Now let's see question number 6. The question is, a ball is rolling from A to D on a flat and smooth surface. Its speed is 2 centimeters per second. On reaching B, it was pushed continuously up to C. On reaching D from C, its speed has become 4 centimeters. It took 2 seconds for it to go from B to C. What is the acceleration of the ball as it goes from B to C? A ball travels from A to D. When it is moving the distance A to B, the speed of the ball is 2 centimeters per second. Then it was pushed again and the speed increases to 4 centimeters per second. We want to find the acceleration of the ball as it goes from B to C. So first let us write what is given. So speed of the ball from A to B is 2 centimeters per second. And the speed of the ball from C to D is 4 centimeters per second. So what is the increase in speed from B to C? Yes, the difference between this will give you the increase in speed. So increase in speed from B to C is 4 minus 2, that is 2 centimeters per second. Now the time required to travel the distance B to C is given as 2 seconds. The time required to travel from B to C is 2 seconds. Now what are we to calculate? We have to calculate the acceleration. Now what is acceleration? Acceleration is rate of change of velocity, or in other words it is change in velocity upon the time taken. So acceleration is change in velocity upon time. What is the change in velocity? Change in velocity is 2 centimeters per second. And what is the time taken? 2 seconds. So we get acceleration is equal to 2 centimeters per second divided by 2 seconds. 2 divided by 2 is 1. Therefore, we get acceleration is equal to 1 centimeter per second square. Now let's see question number 7. The first question. A force of 1000 Newton was applied to stop a car that was moving with a constant velocity. The car stopped after moving through 10 meters. How much is the work done? What all are given? The force applied is given and the displacement also is given. The car stopped after moving through 10 meters. That means that the car was displaced 10 meters. We have to calculate the work done. So first let us write what is given. So it's given force F is equal to 1000 Newton and displacement S is minus 10 meters because force is acting in the opposite direction of displacement. Now what is the relation between work done, force and displacement? Yes, we had learned that work done is equal to force multiplied by displacement. So let's write the solution. Work done is force multiplied by displacement, that is 1000 Newton multiplied by minus 10 meter, that is equal to minus 10,000 joule. Joule is the unit of work done. So you can write the final answer. The work done W is minus 10,000 joule. Now let's see question number 7, the second part. A cart with a mass of 20 kg went 50 meters in a straight line on a plain and smooth road when a force of 2 Newton was applied to it. How much work was done by the force? This is similar to the previous question only. First let us write what is given. What is given? Force F is how much? It is given, it is 2 Newton. And what is the displacement? The displacement S is 50 meters. You have to find out the work done. Work done W is equal to F into S. F is how much? 2 Newton multiplied by 50. That's equal to 100. What is the unit? Yes, 100 joule. The final answer will be the work done W is equal to 100 joule.
With this, we come to the end of the lesson. Thank you and have a nice day.